Hi students, in today's session we are going to find out how to find the number of factors of any number. Before going into finding the number of factors, let us see what a factor is. As you are all aware, factor is a number which divides a particular number completely, or it is otherwise a divisor. Factor is otherwise called as a divisor. So, factors are those which will divide a number completely. For example, I take 6. 6 factors are 1, 1 divides 6 completely, 2, 2 divides 6 completely, 3, 3 divides 6 completely, and 6. So, 6 has 1, 2, 3 and 6 as factors. So, I conclude 6 now has 4 factors. So, this is what we are going to do in this session. How many factors are there for any particular number? Now, 6 has 4 factors. Let me proceed now further to a number called 36, a 2-digit number. The factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18 and 36. So, this counts now to 9 numbers. So, 36 has 9 factors. If the numbers are very small, you can just keep counting them and conclude how many factors are there. If it goes bigger and bigger, writing the factors, listing out the factors like this and concluding becomes very difficult. We are sitting for competitive examinations where getting to our answer quickly is very important. So, we are going to avoid listing out all the factors. So, there is some simple shortcut method to find out the number of factors or such numbers. Let us start with the 6. 6 can be written as 3 into 2. The prime factors of 6 are 3 and 2. 6 is otherwise written as 3 into 2. 1 3 and 1 2 combines to give you a 6. So, 6 is equal to 3 into 2. Now, to conclude this number, let me take the powers alone. Take the powers of these prime factors, 1 add 1 to it, this 1 add 1 to it. So, this becomes 2 into 2 equal to 4. Hence, 6 has 4 factors. Similarly, let us take 36. Express 36 also as a product of prime factors. Now, you would have studied in your lower classes, write 36, use that L-shaped division, express 36 as prime factors. So, to start with, 36 when I divide by 2 is 18, which again divided by 2, 9, 3 times. So, 36 is expressed as 2 power 2 into 3 power 2. The prime factors of 36 are 2 square and 3 square. Now, to this 2 add 1, to this 2 add 1, 3 into 3, 9, 36 has 9 factors. So, now this L-shaped division can also be avoided many a number of times. At times this becomes very lengthy to find out the number of factors. So, directly identify that 36 can be written as either 9 into 4 or it can be written as 6 into 6. Now, express this as product of prime factors. This is 3 square into 2 square. We have come to this form now. Again, this factors can be concluded by adding 1 to the powers, which becomes 9. Simple. So, either L-shaped division, get the prime factors, or directly conclude the numbers and get to the prime factors. Now, this is for 36. Let us consider the number 180. 180 is 18 into 10, which is 9 into 2 into 5 into 2. Now, this is expressed as prime factors powers 3 power 2, 2 power 2 into 5 power 1. As we concluded in the earlier cases, add 1 to the powers 2 plus 1, 2 plus 1 into 1 plus 1 will give you the number of factors of 180, which is 3 into 3 into 2 9 into 2, 18. So 180 has totally 18 factors to conclude about. This is the way to find the number of factors. To put it all concisely, I'll say if suppose you have a number n and you are asked to find the number of factors of this n, write this n as equal to a power p, b power q and c power r, where a, b, c are prime numbers. Now to find the number of factors, to p add 1, to q add 1, to r add 1, multiply, that gives you the number of factors. So remember this to find the number of factors of any number. Now we are going to see how to find the number of odd factors, number of even factors, sum of the odd factors and sum of even factors for these numbers. Let me take the same example, 36. We just saw 36 had 9 factors. Now I am going to tell you how to find out of these 9, how many are odd, how many are even, and sum of such odd factors and sum of even factors. Now again 36 was expressed as 9 into 4, that is 3 square into 2 square. This was how 36 was expressed. Now I'll give a different format to this 3 square and 2 square. 3 square I'll write as 1 plus 3 plus 3 square, and using this 2 square I'll write 1 plus 2 plus 2 square. As simple as that. Why I am writing this is, now 36 we saw has 9 factors. Those 9 factors are given by this. 1 into these 3 gives me 3 factors. 3 into these 3, 3 more factors. 3 square into 1, 3 square into 2, 3 square into 2 square gives 3 more factors. So totally there are 9 factors. This is the concept for writing this 3 square into 2 square as this. Now to find the number of factors of 36, this 3 terms combined with this 3 terms totally gives us 9 terms. So 36 has 9 factors. Now 1 into 1, 1 is a factor. 1 into 2, 2 is a factor. 1 into 2 square, 4 is a factor. This all we listed recently. 3 into 1, 3 is a factor. 3 into 2, 6 is a factor. 3 into 4, 12 is a factor. Similarly, 3 square into 1, 9. 3 square into 2, 9 into 2, 18. 9 into 4, 36. So these are the 9 factors. Expressing 36 in this way gives the number of factors. These are 9. These are the list of odd and even factors. Now we are going to see how by using this expression you are going to count the number of odd and even factors. Right. Now let us take how many of these are odd. Here these 3 are odd numbers. These 3 odd numbers will combine this one single odd number. Hence I get 3 from this, 1 from this, 1 into 3. 3 odd numbers are there totally out of this 9. Now coming to the number of even numbers. Even numbers are those which are obtained while multiplying by 2. Now you have 2 even numbers in this bracket. These 2 even numbers will combine with these 3. From the first bracket 3 numbers, from the second bracket the 2 even numbers. So totally 3 into 2, 6 even numbers are there in this total 9. Hence I get totally 9 factors for 36. So to repeat again, express the number as product of prime factors. Whatever be this, start from 1 and conclude, keep adding till this 3 square. Suppose I have this as 3 power 5. Now I am going to express this as 1 plus 3 plus 3 square plus 3 cube plus 3 power 4 plus 3 power 5. So whatever is this will decide how you are going to express this term. And so now this 2 square is expressed as 1 plus 2 plus 2 square. To repeat, these gives you totally 9 factors. 1 into 1, 1 into 2, 1 into 2 square and so on. So totally we are concluding we are going to have 9 factors. Next we are going to see how to find the sum of these 9 factors, how to find the sum of these 3 odd factors and how to get the sum of these 6 even factors. Now, the sum of all these 9 factors is what we are going to find. The sum of all these 9 factors are nothing but the total of this. Always we are not going to list out the factors. This expression is going to help us to conclude what the sum will be. Now, as I told you earlier, this multiplied to the 3, this multiplied to the 3 gives you these factors. So, I am just going to add these and multiply, that gives us the sum. 9 plus 3 12 plus 1 13, the first bracket sum is 13, that 13 multiplied to the second bracket sum, which is 4 plus 2 6 plus 1 7. So, 13 into 7 91 is the sum of all the factors of 36. You can check the sum of these, that is going to conclude 91. Now, similarly, how to find the sum of all the odd factors? How did we find the number of odd factors? The odd terms here and the odd terms here. The same concept, the sum of the odd terms from this bracket and the sum of the odd terms from the second bracket is going to give you the sum of odd factors. Now, this sum already we have, which is 13, and here it is 1. So, the odd factors will add to 13. You can check 1, 3 and 9 are the odd factors whose sum is 13. Now, going to the sum of even factors, as we saw earlier, these two even will combine with these 3 odds to give you the even sum. So, now here from this bracket the sum is 13, this bracket's sum is 4 plus 2 6. So, 13 into 6 78 is the sum of all even factors. This totals to 91. This is the method to find the sum of all the factors, sum of the odd factors and sum of even factors of a particular number. Let us take now one more example to find out the number of factors, number of odd even factors, sum of the factors, sum of odd even factors. So, let me take the number 60. 60 is expressed as 6 into 10, or use the L-shaped division, get to the answer. This is 3 into 2 into 2 into 5, that is 3 power 1 into 2 power 2 into 5 power 1. Now, to express this, I can write this as 1 plus 3, 2 square is written as 1 plus 2 square, and 5 power 1 is written as 1 plus 5. Now, as before, the number of factors, total number of factors, the 2 terms here, the 3 terms here and the 2 terms here will combine to give you the total number of factors, which is 2 into 3 into 2. So, totally there are 12 factors of 60. Odd factors, how many of these 12 factors are odd? These 2 odd numbers, this odd number and these 2 odd numbers, that is 2 into 1 into 2, 4 of these are odd. Even the 2 even numbers with these 2 odd and these 2 odd, which is 8, gives you the total number of even factors. Totally, you get 12 factors for 60. Similarly, to find the sum of these odd factors, sum of these all the factors, sum of even factors and sum of odd factors. To find the sum of all the factors, I am going to get the sum of this, this and multiply, which is nothing but 4 into 4 plus 2 6 plus 1 7 into this is 5 plus 1 6 will give you the total number of factors, the sum of all the factors. Even will be taken care of by this combined with these two. The sum of this is 6 into 4 into 6 gives you the sum of even factors, and the sum of the odd factors will be 4 from here, 7 from here and 6 from here gives you the odd factors. 4, only 1 here, these two becomes even. So, 4 into 1 into 6 gives you the sum of all the factors. Sum of the odd factors is 24 and this is 6 into 6 into 4, which is 144. This gives you the total 168. To conclude the session, I am going to take a number 3072 and let us check how many factors will this have. Now, 3072 To find the number of factors of this 3072, a very big number, to take the L-shaped division, very lengthy. To express this as a product of primes is also very lengthy initially. So, using the divisibility test what you have learnt earlier, see what number is divisible, this is divisible by. Now, let us start with 2, you know very well this is divisible by 2. If I start with 2, it becomes very lengthy. So, let us move on to the immediate next number 3. Is this number divisible by 3? To find out if a number is divisible by 3, you will have to add the digits. If the sum of the digits is divisible by 3, we are going to conclude that the number is divisible by 3. Now, 3072, when I add the digits 3 plus 0 plus 7 plus 2, which is 12, very clearly this is divisible by 3. So, get rid of the 3 from this 3072 and let us see what happens to this. If I remove 3 from here, I am left out with 1024. Now, this is a very familiar number to all of us. This 1024 is nothing but a power of 2. So, easily this gets factorized now. So, this is 3 power 1 into 2 power 10. Using the methods what we have done before, now you can conclude how many factors will this 3072 will have, how many of them will be odd, even, their sum, all that can be concluded. Let me just take the sum of, let us now find only the number of factors of this 3072. Now, when I am expressing this, I will express this as 1 plus 3 and 2 power 10 will be expressed as 1 plus 2 plus 2 square till 2 power 10. Now, to find the number of factors, following the same procedure what we did before, this has 2 and this has 11 factors. So, totally there are 22 factors in 3072. Now, the same procedure to find the odd numbers here 2, the odd number here only 1. So, 2 odd factors. To get the even factors, even numbers multiplied to odd gives you even. So, all these 10 from the second bracket, 2 from here gives 20 terms which are even. So, totally this comes to 22 factors. Making use of the same procedure what we have done before, you can find the sum of the factors, sum of the odd factors, sum of even factors of this particular number. So, with this session, we will conclude how to find the number of factors of any number, which plays a very important role in answering many of the competitive examinations. So, with this, we are concluding the session on finding the number of factors, the number of odd even factors, the sum of odd even factors of any number. For further reference to solve questions based on this, you can refer to the study material. Thank you.